Hello everyone, my name is Ashar Rahman. I am currently pursuing my Bachelor of Technology from Dr. Ambedkar Institute of Technology for Handicapped Kanpur. I am currently in my final year with the specialization of Computer Science and Engineering. I am currently intern in Emertxe for the Embedded System role. Today I am represent. Today I am here to represent my project microwave oven simulation, which was assigned to me during the internship. So let's get started about the internship. Like the Emertxe Information Technology Bangalore. The internship is for the 4 weeks organization. It's structured and the standard. Learning with the implementations, the students reports, free resources and tools, project-based learning, and weekly evolution of the students. Next, learn topic during the internship, like introduction to C, conditional statements, loop and operation, array and pointers, functions and strings, store classes, introduced to embedded system and microcontrollers, MP labs, compilers, XC8 compiler, MLabs, introducing to various peripherals of microcontrollers, given multiple quiz and Disha workshop. Now let's talk about the contents that we are going to go through the videos, like what is microwave oven, what are the requirements, like what is the embedded system, what is the microcontroller and microprocessor, and microcontroller versus microprocessor, picsimlab, CLCD, matrix keypad, ISR, timer, and project implementation. At the last, we like to share you a live demo to implement the project. Let's move forward. The introduction to the microwave oven. A microwave oven is a kitchen appliances that use microwave radiation, especially microwaves, to heat and cook food quickly and efficiently. Microwave oven typically comes with several cooking modes or getting to accumulate different type of food preparation. Like there are the four modes. Like first one is the micro mode, second one is a grill mode, and third one is the convection mode, and fourth mode is a start mode that user can start it to. We look all modes in details. Like moving to the next mode is micro mode, like microwave mode. It is used for the quick and efficient heating, uniform cooking. The microwave mode is a standard mode used for quick and efficient heating of a food. It's a particularly effective and reheat leftover and heating a beverage in the matter of the second. Microwave can provide relatively uniform heat throughout the food, although it may not always brown or crispy. The food texture. It excellent for the even heating. This is without need for added the fat and oils. The second mode is grill mode, which is used for browning and crispy, versatile cooking. Grill mode is uses a heat element on the top of the microwave to brown and crisp the top of the dish. It's perfect for creating the golden crust on the cheese roll, melting cheese, and achieving a grill texture on the certain food. Uh, it is also the allow more versatile. The grill mode allow for more versatile in cooking as combines microwave heating and with grilling. Give you the option to prepare a wider range of dishes from the cheese to the sandwich like that. Now, third one is convection mode. It is used for baking and roasting crispy and or texture. The convection mode utilizes a fan and the heating element to circulate hot air, make it ideal for baking cookies, cakes, and roasting meats. It provides even cooking and browning similar to the traditional oven, crispiness and texture. Like convection microwave are known for producing this with the crispy um, exterior in, and tender interior, enhance the texture and the flavor for the various recipes. The fourth mode is the start mode, basic heating. The start mode is a default setting in a microwave and is used when you want to heat or cook something without using any specific cooking mode. Simply input the desired timer and the power level, then press start. Then start mode is a highly customizable, allowing to manually adjust the cooking time and the power level on the base of your cooking needs. It is a versatile option for a various cooking and and tasks. Let's move forward. Requirements like to build microwave oven simulation, we need some ID or compiler. There is the list like one is mplab.xid, xc8 compiler, picsimlab, or uh, PIC16F, 877A, 16 cross 4, CLCD, tactile switch, KPM, and the timer to adjust the timing, to set the timing. Like now we learn what is embedded system. Like embedded system are the specialized computerized system designed to perform the dedicated function or a task within the larger system. They are embedded into the various devices and application range from the consumer electronics like a smartphone, washing machine, uh, to industrial machinery, CNG machinery, automobile control. The the prime the primary purpose of embedded system is to control, monitor, and manage the operation of these devices effectively and autonomously. What are the characteristics? There are something like real-time operation, resource constraint, reliability, integration, and customization. In in real-time operation, many embedded system operation in a real-time, meaning they must respond to input and perform a task within a strict time constraint. This is a critical for application like automobile safety system and the medical devices. Like what the example of is like airbags in the car system. Like second one is resource constraint. Embedded system often have limited computing resource, including memory, processing power, energy. Designers must optimize software and hardware to work within these constraints. Like third one is reliability. Reliability is a paramount in the embedded system, especially in safety critical application. Failure can have the serial consequences and extend extensive testing and reduction for the common. The next one is components of embedded system. In the embedded system, there are the many like input devices, interface, driver circuit, processor, program memory and data memory, timer, power supply, reset and oscillator circuit, serial communication port, system application and specific circuit, interrupt controller, parallel ports, output interfacing driver circuit. There are the many components in the embedded system. Now, now moving forward to microprocessor and microcontroller. In microprocessor, there are a microprocessor which includes a microcontrol unit like arithmetic and logic unit, a CPU, a register, which is connected with the data address bus, data bus, and the control bus. Whereas the microcontroller includes like a CPU, input-output ports, RAM, ROM, counters, and timers. Like there are many buses like address buses, data buses, and control buses, which is used to which is used for traveling the data from one place to another. Now the microprocessor versus microcontroller. Like in microprocessor are widely used in the computer system, whereas microcontroller are widely used in the embedded system. In microprocessor, it has only CPU embedded into it. But in a microcontroller, it has a CPU, a fixed amount of RAM, ROM, and other peripheral devices all embedded on it. In microprocessor, in case of microprocessor, we have to connect all the component externally, so the circuit become large and complex. Whereas in microcontroller, all the components are internally connected in the microcontroller. So the circuit is like small. The size of the circuit is small. In microprocessor, it consumes more power, but in microcontroller, it consumes less power than a microprocessor. In a microprocessor, it has a less internal register storage, so it can to rely on external storage. So all the memory operation are called out using memory-based internal commands, which result in high processing time. But whereas in microcontroller, it has many register to processing time is very less in a microcontroller as compared to the microprocessor. Now moving forward, like this is the architecture of picsimlab. Picsimlab, it is an architecture of PIC 16F877A, in which it is their RS23. It also LEDs, buzzer, digital keyboards, SSD, matrix keyboard, CLCD, and GPIO, like IC2, RTC, EFORM, from LM35 temperature sensor like ADC. In Pixel Lab, this is the architecture. Like, okay, you understand. The next thing is CLCD. The CLCD is standard for character LCD, or like a character liquid crystal display, in which we can display, like here you can see that we can display our outputs. Like in Pixel Lab, there are the two type of display. Like the first one is 16 cross 2 display. Then the second one is 16 cross 4 display. Uh, in 16 cross 2 display, we can use two line of display. In 16 cross 4 display, we can use four line of display. It displays the guy's value and some special character. There are the two type of communication mode, like one is 4-bit mode and second one is 8-bit mode. The next one is tactile switches. It is the switches whose operation is perceptible to touch. The switch is used to select the mode of operation and to enter the temperature and time in our project. The switch produces bouncing effect when a switch is pressed. The next one is matrix keyboard. The matrix keyboard is consist of grid structure, digital output, cost effective. Matrix keyboard have a grid of a button organized in a row and a column. We can say in a row and a column, we have a grid-like button. Yeah. The second one is the digital output. When a key is pressed, is created and a electrical connection providing a digital output. It is a cost effective. They are compatible. The cost effective input device used in a various electronic application, including like a calculator or a remote control. The next one is like interrupts. What is interrupts? An interrupt is a communication process set up for in a microprocessor or a microcontroller in which an internal and external device request for the MPU or MCU to stop processing. Then the MPU or MCU acknowledge the request uh, and attend the and acknowledge the request and attend to the request. Go back the processing where it was got interrupted. Next one is ISR. ISR means interrupt service routine. SIR is a software routine that that hardware invoked in response to an interrupt. ISR attained the request for the interrupting source by clearing the interrupts flag and should save the register contain. They may be affected by the code in ISR. It must be terminated with the instruction RTI retry. When an interrupt occurs, the MCU completes the instruction being executed. Then it disables global interrupts, enable the places and the address from the product counter on one the click. Like next one is timer. What is timer? Timer is an important application in my embedded system, which is a default peripherals which maintain the timing of the operation in syncing the system clock and the external clock. It has the main applications such as measuring time, generating delays. Timer and the counter is a software designed to count the time interval between the events. Resolution, which all which also called register with, like it is a two type 8 or 16 or etc. Like a tie or a quantum. Tie referred as the change from one number to another number. It may be up count or a down count. Then quantum, which depends on the system clock setting, is a measure on time which is responsible for a tick. Scaling may be a pre-scaler or a post-scaler. Like here's the code for the microwave simulation. The cooking mode display, start mode, micro mode, grill mode, convection mode, power on a screen, like what we see on the screen, like CLCD screen, cooking mode, clear display. We have a code of a clear display. Like we have the code of set timing. Now we have to build this. Now the building it successfully. Then we have to run this. Like this is the picsimlab. Okay, here we have to load exe file. Like this is the screen of CLCD. Here we have to load that Excel file that we build. Like this is the file we have to open it. You can check the path. Like yeah, like micro, grill, convection, and start. There are the four options. We have to press one, power equal to 900 watt. Then we have to start. Then we have to enter some timer to start it. We have enter. To clear, we have a star button, or to enter, we have a hash button. Like you can see, this is our hash button to enter. So this is enter. The fan is moving. The cooler. This is the cooler, and this is the temperature here. Press 5 for pause. So cooler is stop. Press 4 for restart. Like time is up. Now the we have to like a convection mode. Now we have to set the temperature. Like we set 500. Then we uh, the temperature should be like something less than 500. We enter the 100. That's yeah. It's running. The timer was the 50 second. The countdown is start. Like it's preheating the oven. In 50 seconds, the oven is preheated. Now the preheating is done. Inside the oven, the temperature is set up to 100. Now we have to set some temperature. Now the last mode is the start mode. It is the default mode which you can use for cooking or reheating the food. It is like there are the four options like start, pause, resume, and stop. You can use 4, 5, or 6. Like it's button to click it. It's a tactile button. Like it's done for now. You can watch it all the video. Or like this is a demo video, and like thank you for watching the video. You can share it. Like thank